Hey, welcome to iFlip for Math Mathcast, lesson 18-2, bar graphs. I'm Mrs. Gooding, and all our quote and all of our photos tonight are provided for us by Brian, who is a skater, and so one of the people that he really admires is Tony Hawk. And Tony said, "Snowboarding is a spawn of skating, and skating is my passion." And I think Brian would probably also tell you that skating is his passion, but he also really enjoys math. So you can enjoy more than one thing, and you can do more than one thing when you grow up. Our learning goal tonight is to use the Magnificent Seven strategy to create and interpret bar graphs. So here are our individual lesson learning goals. Number one, it's so important that you memorize the Magnificent Seven, but you should remember all the songs that we sing for each place that you stand on the graph. Remember when we made that giant graph outline on the floor in the classroom when we took turns standing in different locations and singing the songs to help us remember. We're also going to practice graphing data tonight, and we're going to interpret data. So the culminating thing we're going to do, that means the final thing, is going to be to do the graphing the data, so that you will need to use the graph paper that you glued into your journal for tonight. If you forgot it, you're going to need to go to iflipformath.org so that you can print out a graph so that you can glue it into your journal. Tony Hawk is doing some pretty cool things here, some pretty brave things. Sometimes it takes a lot of courage to do math too. So this is pretty fun, easy stuff, but I want you to enjoy it. Our vocabulary tonight is bar graph and double bar graph. So a bar graph is simply a graph that uses bars, those are rectangular shaped, to show and compare data that tells how many or how much. A double bar graph is exactly the same thing, except instead of just one bar, there are two bars connected to each other that show a comparison between two similar sets of data. I'll give you lots of examples. Here are the Magnificent Seven. The x-axis, which of course is your horizontal axis. The y-axis, which is your vertical axis. And if you have a hard time remembering which is which, look at that capital Y. There's a straight up and down line and then a V on the top. The V on the top can stand for vertical. And the stem on the Y, well, that just shows you a picture of what vertical looks like, straight up and down. So that's going to be the axis that runs straight up and down. The x-axis label goes right underneath the x-axis, and the y-axis label goes right next to the y-axis. The title, of course, tells what our graph is going to show us, and our scale intervals, which are pretty important, we're going to be talking about those a lot tonight, are the numbers that go up the side. Our point of origin is the 0 at the corner of the graph. So I want you to take a look at this graph. This is a pretty good graph. It's been created by a company so that you can see an example of a graph. And it's a double bar graph, meaning you can see that there are two bars connected. And the gold bars represent boys at Redwood Secondary School, and the yellow bars represent the girls at Redwood Secondary School. And what it's showing is how much they use the internet, and they're comparing boys to girls. And we've got our x-axis across the bottom. We can see it wherever our 0 is, our x-axis comes out horizontally. And we can see our y-axis, which comes out from the 0 straight up and down. Something is missing though. One of our Magnificent Seven is missing on this graph. So I want you to look at it, pause it, and look at it for a minute to see if you can figure out what it is, and write that down. Okay, did you put the x-axis label? We see years listed across, but we don't see the label that tells us what those are. Those are the years that they did this study. Then we see a y-axis label. It's number of students. There's a great title, Internet Use at Redwood Secondary School by sex, boy or girl, 1995 to 2002. So that's three things: title, x-axis, actually it's more than three things, y-axis, x-axis label, y-axis label. We've got 5 things, so we know we need 2 more. Our point of origin, which is the 0, that's where all of our data begins, and our scale interval, which are those numbers going up the side. And this is what's important about a scale interval. You can't just jump from 0 to 400 and then go 401, 402, 403, 404 without using a special symbol. and we'll be teaching you that in later videos. What I want you to notice, take a look at all those numbers going up the side and see if you can figure out the pattern. Pause it while you write down what the pattern is. Good. Did you say the pattern is add 50? You would be right. If you started at 0 and you add 50, your next interval is going to be 50. You add 50 more and you get 100. You add 50 more and you get 150. The idea is to choose data or to choose intervals that you can measure the least amount of data and also measure the greatest amount of data. So that's a range. If we have data between 50 and 350, then we want to make sure that we start at 0 and go to 350. And each of those intervals has to be exactly the same. So I should be able to add the beginning number to every number and get the next number. So 0 plus 50 is 50, 50 plus 50 is 100, 100 plus 50 is 150. It doesn't matter what you choose to use as your intervals, but it has to be consistent as you go up. The other thing is you have to number all the way to the top, even if your data isn't going to go all the way to the top. You have to number all the way to the top of your graph. Some examples of intervals that we use a lot in 5th grade or maybe in 4th grade were you might number by 2s. You might number by 1s if your range of data is very low. You might number by 5s. You might number by 10s. You might number by 20s, 50, 100. Now, think about what would be the problem as you have intervals that are bigger and bigger and bigger. What makes this a little bit more difficult? Pause it and think about that for a minute. I'm so curious to know what you wrote down. I hope you'll share it with me in class tomorrow. What makes it more difficult is the larger your interval is, the harder it is to accurately read the graph. So if you look at that first orange bar or gold bar over 1995, you can see that it's somewhere between 100 and 150. We can tell that it's less than 125 and probably less than 115, but it's difficult to tell exactly what that number is. The smaller your intervals are, the more easy it is to read a graph. We can kind of solve this by taking the number that is actually represented and just writing it on top of the bar. So if that is 107, we could write a little tiny 107 just at the top of that bar. The other thing, do you notice that each of the bars is evenly spaced? So there's a nice even space between the 1995 bars, there's 2 of them, gold and yellow, the 1996, the 1997, the 1998. It isn't a big space and then a little space and then a big space and a little space. They're very evenly spaced. If you use grid paper, that's really easy to do. If you skip one grid space each time, it will be just right. Now, we're going to practice interpreting this data. Did boys or girls use the internet more in 1999? Pause it and push play when you can answer that. Okay, did you put that in 1999, boys used the internet more because the gold bar is taller than the yellow bar? The gold bar is over 300, where the yellow bar is less than 300. So you could look at that graph and figure out exactly what kind of internet usage those kids were doing in that year. Here's another graph that I wanted you to see. All of these graphs are going to be a little bit different because you're going to see different graphs all over the place. If we were ranking this graph on a scale of 1 to 7 or 0 to 7 based on our Magnificent 7, what would you score this graph? Pause it and push play when you've written that down. Okay, let's look and see what's there. I would give a point for a title, and they capitalized all the words in the title that are important, just like in a book. I would give a point for the x-axis and the y-axis. I would give a point for the x-axis label, which is hours, and the y-axis label, which is number of students. Then I also have my point of origin, 0. So far, we're at 6 points. Now let's check out their scale and the intervals that they used. Are they all evenly spaced? Did they start at 0 and go all the way to the top? They did, and if I start at 0 and add 5, I get 5. If I add 5 more, I get 10. 5 more is 15. 5 more is 20. 5 more is 25. goes all the way to the top. They did a great job of using the same interval for each data point there. Now, let's answer some questions. What is the number of hours that most students watch TV? Pause it and push play when you've written that down. Did you write 9 to 11 hours? You can see that the 9 to 11 hours, if you kind of connect over and look, it's not quite half of 30 and 35. It's probably about 32. So 32 students watched about 9 to 11 hours of TV. I hope that's a week and not a day. Or they're staying up pretty late at night after they get home from school. If you look, which one watched the least? How many students watch the least amount of hours? Pause it and push play when you've written that down, just for fun. Yeah, did you put about 4 students watch 0 to 2 hours? Good job. Look at all of those data. Those are ranges of hours that they've listed there, and that is okay to do. Although frequently, we would use a histogram whenever we're using ranges in a bar, and we would smush our bars together. We'll be talking about that later, but it does let us see about how much TV kids are watching. Here's another graph. Let's evaluate this graph on a scale of 0 to 7. Go ahead and write down how many of the elements it has of the Magnificent 7 scale. Then push play when you've written it down. Okay, let's take a look. It has a title, capitalized really nicely. It has an x-axis and a y-axis. It has an x-axis label and a y-axis label. Favorite color and number of students. It has a point of origin, and its intervals go 0, 5, 10, 15, 20, 25. They count by 5s. If you can skip count, this will be really easy for you. As I'm looking at it, I kind of wish they'd had one more number right there at the top, but it's still a really good graph. They've skipped an even amount pretty much between each bar so that we can see them very clearly. And we can read them pretty easily too. So we're going to do some interpreting. How many students said that green is their favorite color? Pause it and push play while you write that down. Did you write 10 students? That was pretty easy because we could almost get a piece of paper and line up from the top of our bar, our green bar, all the way across to our scale, and it was pretty close to the 10. The pink one might be a little harder. It's way over at this end of the graph, and it's pretty far from the scale. So using that sheet of paper to line up with the top of the pink bar and run it across to our scale will help. I think it's about 3. It would be interesting to see if you and I came up with the same numbers for all of them. Again, because 5 is a pretty large interval, sometimes we're having to estimate a little bit on exactly what each bar is representing. Writing the number on the top makes that less of a guessing game. This graph is a little bit more grown up. This is looking like a 5th grade graph. Let's see, I want you to give this graph a score on a scale of 0 to 7, and then push play when you've written that number down. Let's see if what I put is the same thing as what you put. It has a great title. It tells us that on there. It has an x-axis label and a y-axis label, already even labeled for us. It has an x-axis and a y-axis and a 0 point of origin. So the tricky thing will be looking to see if our scale is accurate. Did they number all the way to the top? They did. Are the intervals the same from the bottom to the top? Let's see, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. They skip counted by 10s. That's an even number of difference between each number. Now, let's see. Number 3, which student had the highest attendance in science class? Pause it while you write that down. Don't forget to look at the key to help you figure that out. Did you write Chuck? See, the attendance is represented by the striped bar. So Chuck's attendance is the striped bar over Chuck's name. The solid bar is represented by the science grade, or represents the science grade. He attended, let's see, almost 100%. His science grade isn't quite 100%. It looks more like maybe 92. Again, it gets a little trickier to read that graph because the intervals are 10, and there's a lot of numbers between 90 and 100. Let's see what our next question is. Which student has the biggest difference between their attendance and their science grade? Now we have to look at all of the students' data. Pause it and push play when you've written that down. Did you write Ben? Let's look at those. Al's difference, it's about maybe 87 or 88 and maybe 78, so maybe 10. Ben's difference between the blue bar and the striped bar, or this grade and the attendance bar, is about 66 and 46 or 47. So that's almost 20 right there. Chuck's, you can tell, is much smaller, and so is Dan's, and Earl's, and Fred's is equal. So there's no difference at all between the rate of his attendance and the rate of his, or what his grade is. So you can tell a lot of different things. Who had the best attendance, who had the best grade, and how much maybe the school attendance impacted the grade. Some students went to class all the time and did really well, like Chuck. He had the highest grade and the highest attendance. Fred's attendance also probably impacted his grade. Ben only has about 47% attendance, which is really bad. He's going to class less than half the time. But his grade is up to a 67%, and that's not a good grade. It's still a D, but it's better than what his attendance rate is. So it's kind of fun to interpret graphs to see how much different things impact other things. Data is really cool. Number 5, the students in Mrs. Gooding's 5th grade class filled out a sports survey. The chart shows the number of students who chose each sport as their favorite sport. Construct a bar graph to display the data. There it is. That's your graph. That's your data chart that you're going to take that information and put it on a graph. And I'm going to give you a hint. The left column is always your x-axis, and the right column is always your y-axis. Remember way back when we did coordinates and x always came before y? The x-axis always was plotted before the y-axis was plotted? It's the same thing. This is your x-coordinate and your y-coordinate. So you want to make sure that you graph them according to the way they're charted. Go ahead and pause it and push play when you've constructed that graph on the graph paper that I gave you in class. Does your graph look something like this? It doesn't have to look exactly like this. Remember, every graph's going to look a little bit different. You may have chosen different intervals, but let's see if this graph has everything that we want. It has a great title with good capitals. It has an x-axis and a y-axis. It has an x-axis label, sport, and the y-axis label, number of students. Now, it has a 0 or a point of origin. Origin, remember, means where everything begins, where it begins. So that's where we're starting to look at our data and where we begin our scale. Now let's check out our scale. Are the intervals equal? Did they go all the way to the top? They started at 0, 5, 10, 15, 20, 25, 30. That's counting by fives. All the intervals are even. And can we read our graph pretty easily? Are our bars evenly spaced and labeled? Baseball's labeled. Do you see how they put their labels out this way so they'd have a little more room on their paper? It's okay if you did that. If you wrote them straight up and down, that's okay too. We could definitely answer questions from this graph, like how many students chose baseball? How many students do you think chose baseball? 25. How many chose basketball? That one's a little harder to read because there's 5 difference between 15 and 20, but I'm thinking it looks like 17 maybe? If you said 16 or 17 or 18, that's probably a good estimate. Gymnastics might be a little easier. It's close to 15. What would you have said? 14? Me too. And then soccer, I would have estimated about, let's see, what do you think? 27? 28? And tennis, what do you think? Yeah, I think about 12. 11, 12. I think that's pretty close. So again, if you write those numbers actually on top of each bar, you would be able to tell exactly what those numbers were. Can we look back at our chart and figure it out? Absolutely. But a lot of times people don't put the chart next to the graph, so you want to be able to get your data very specifically from the graph. You may have decided to use intervals of 2 and count it up by 2s. That would make your graph really, really easy to read, and maybe even easier to read than counting by 5s. So that was probably a good idea. It's time to challenge yourself already. When you come to class tomorrow, you're going to be making a lot of graphs and interpreting a lot of graphs. So if there was anything you missed, you want to go back over it and look again. But I think you can do this challenge problem, so I want you to try. Okay. Scores on a fractions test with and without preparation. I'll tell you that with and without preparation means with being taught the information or without being taught the information. So what you're probably looking at is pre-test data and post-test data. And you can definitely tell a difference. Explain the findings displayed on the graph in your flip journal and come back tomorrow ready to share your work with your teacher and your team. Let's see what you guys decide. Should you study? Should you try and learn or not? Finishing up. Review your learning goals. Have you mastered them all? Are you at a 1, 2, or 3 level in your learning? Remember, 1 means, oh my gosh, I cannot figure out the Magnificent 7. My graphs are messy. I need to work on getting all of my elements in my graphs, all of the Magnificent 7. I need to work on my bars being neater. I need to work on interpreting data. 2 means I've almost got it. I'm just maybe leaving off a label or leaving off a title or forgetting to capitalize my title. So think about those things. If you're a 3, you did a really great job every time. Write down any questions you still have because you may have a lot of questions and I want you to be able to ask them tomorrow in class. Yippee bar graphs, you've completed lesson 18-2, bar graphs. Check out that picture of Tony Hawk. That's his daughter. Probably should be wearing helmets when they're skating like that, but it is a pretty cool move for a dad to do with a daughter. You'd have to be really good like Tony Hawk to do it. Please don't try this at home. I can't wait to see you tomorrow.